Welcome to an introduction to one-way ANOVA. So the whole idea behind one-way ANOVA, why we use one-way ANOVA, is to compare population means for multiple populations, not just comparing two population means. So we want to compare the means of multiple populations, not just the two populations as in module 23 through 25. So we're comparing the means of multiple populations, not just the two populations as in modules 23 through 25. So here we have an example scenario. So a university wished to compare the study skills levels of the different years on campus. A researcher randomly selected 10 students entering their first year, 10 students entering their second year, and 10 students entering their third year. The researcher had all of the selected students take a study skills test, which was scored out of 100. And the researcher then compared performance by year. The data is recorded below. Can we conclude at the 5% significance level that not all 3 years have the same average performance? So basically, we're just trying to see, do the samples provide enough evidence that for the population means being different? So here's the data listed. So first year scores were 56, 72, 83, 68, 92, 67, 72, 83, 64, and 73. Second year scores were 62, 78, 77, 85, 89, 95, 68, 75, 83, and 71. And the third year scores were 85, 62, 78, 97, 72, 79, 85, 65, 88, and 91. So these are kind of backwards in the box plots. The first year is here. This is the second year box plot. And the third year box plot. And then the one at the bottom is all of the scores together. So all 30 students. So if we look at these, we are currently looking at the medians. The third year is skewed slightly to the left. So I would guess that the mean for the third year will be somewhere around 80 or in that region. The second year students is fairly symmetric. The mean's probably not much different from the median, but it looks like it might be a tiny bit above. For the first year students, maybe the mean's going to be somewhere around here. And then for all together, it looks like the mean might be somewhere around here. We could find the actual scores, but here I'm just sort of approximating. So the sample means are different. The first year sample mean looks to be in the low to mid 70s, as opposed to the second year in the upper 70s and the third year around upper 70s or low 80s. So note the sample means are different. So we've got our first year is around the low to mid 70s. Second year, we're looking at the upper 70s. And the third year is somewhere in the upper 70s or low 80s. But at the same time, there was an awful lot of overlap in the typical regions for all of these. So, but there was not a lot of overlap in the typical regions. For the 3 samples. So essentially, who's to say if we took another sample that, or if we took 3 more samples, that they wouldn't change position, right? So if we took 3 more samples, essentially, would we still get similar results? Or maybe would the first year mean be higher for another sample? So might the first year mean be higher in a different set of samples? So essentially, what we're looking at in one-way ANOVA will be at what point are the sample means different enough for us to conclude that the population means must also be different? So a big question. At what point are the sample means different enough for us to conclude the population means are different? So one-way ANOVA will give us a way to come up with a p-value so we can make the same judgment we've made in previous hypothesis tests. In our next video, we will look at what the hypotheses look like for one-way ANOVA, as well as what is necessary for us to be able to run one-way ANOVA and have the results be statistically sound.